Hey, good morning, guys. Mr. Darling here again. We're going to start with lesson 6-9. Very important lesson here. We're going to talk about the traditional, kind of the way you'll normally solve equations. I know we've talked about trial and error, and we've talked about pan balance, and we've talked about bar models, which are all great strategies to develop algebraic thinking. But the most efficient way is to be using inverse operations. So our I can statement is, I can solve equations using inverse operations. Okay, so we're going to show you what inverse operations and how to solve using this strategy. All right, so the first problem, we'll just do some basic one-step problems that you guys a lot of times can just use trial and error and your common sense, but want to show you how this works and what we expect to see out of you. Okay, so if our variable is y here, y, and we're going to add 32, and we're going to get up to 48. So a lot of you can do some mental math, and you would know y is 16. 16 plus 32 is 48, okay? So, but if you're not able to do that in your head, which you'll get fractions and decimals, you got to understand this process. So really how this works, again, thinking like a pan balance kind of, these two sides have to stay equal. So if I have y and I added 32, I got bigger by 32. My goal is to isolate the variable, which means I want to get y by itself. I want to get this y equals what? Because then I know my answer. So in order to do this, I kind of have to undo what they did to y. So if they add 32, I got bigger by 32. To undo that, I subtract 32. Okay, and that'll be like it never happened. Those inverse operations undo each other. So I'm just going to write it up here, and I'm going to subtract out 32, because if I add 32 and subtract it, that becomes nothing. Okay, this is like 32 minus 32 is nothing. Okay, so you could cross it out and put, well, that becomes like a 0. Don't have to. And then y plus 0 is just y. And then remember, with our pan balances we've been working on in bar models, you got to get things to stay balanced. So if I subtract 32 from one side to keep the teeter-totter or the pan balance to stay the same, we would have to subtract 32 from the other side. And if I take 48 minus 32, I get 16. So y does equal 16. And the most important step, you guys know, is that if you plug that back into the equation, if you plug it in and substitute, y is 16, we know 16 plus 32 is 48. Okay, and sometimes you can do that mentally and don't have to show work, and you know you're right. You can guarantee yourself you're right if it works out and equals the way it's supposed to. Okay, same thing here. If I start with the variable of x and I subtract 212, to undo that, to isolate the variable and get x by itself, the inverse of subtracting 212 is to add 212. Okay, again, if you're like at x and you take away 212, you got to add 212 to get back up to x to where you started. Again, I know we talk about weight a lot. That'd be one example. So these undo each other, and it's like nothing happened. Negative 212 plus 212 is nothing, or 0. Okay, so in this case, it isolated the variable. And then remember, the pan balance, you got to keep it weighing the same. If I add 212 to this side, I have to add 212 to this side to keep it equal and balanced. And I'm not going to do the work right here. I'll do it mentally. But 890 plus 212 is 1,102. Okay, so I've gotten x isolated. I know what it is now. So I'm going to go ahead and plug it back in here. And if I say x is 1,102, I know I'm supposed to subtract 212. So I'm going to subtract 212. Get my comma a little big there. And if it equals 890, I know I'm correct. Okay, so I'll decompose some units of higher value here. And 10 minus 2 becomes 8. And I see that it equals 890 when x equals 1,102. It equals 890 like it's supposed to. So then, again, I know I'm correct. I've used those inverse operations to solve to find out what my variable is. Basic one-step problems there, okay? And on your exit slip, you guys are actually going to have a word problem. There's going to be another video after this that's a more complex word problem. You have to write the equations yourself and then solve the problem using these strategies that we're working on here. And in year 1, you're going to see on your exit slip, one of them is going to be a two-step problem. So we'll kind of show you how that works here. All right, so for this next problem, let's have 3x, number 3 example here. 3x minus 4 equals 86. And again, this is about as complex as we're going to get this year. in some of the advanced groups and things, we would get in stuff where we incorporate fractions and decimals, because then you're going to have to add, subtract, multiply, and divide fractions and decimals, which gets a little more complex. But today we just want to understand the operations of how to solve with inverse operations. Guys, when you solve these, the variable, you're going to keep this until last, okay, when your variable is x times 3. You're going to undo it, and we're going to take care of this 4 first. So if I have 3x and I subtract 4, how would I undo that? I would add 4, and then it's like it never happened. So if I add 4 to this side, okay, that is like it never happened. It becomes nothing. So then I must add 4 on this side to make sure they're both going up by 4 to stay equal. So this side becomes 90, and this side becomes 3 times x. Okay, so if we have 3 times x equals 90, a lot of you right now could just do your trial and error and guess and check and know that x is 30, because 30 times 3 is 90. So sometimes you get it to a point that you can just solve it that way, and you don't even have to finish with inverse operations. Okay, but to show how to do it, remember, this is x times 3. So if I took x and multiplied it by 3, it got 3 times bigger. How do I undo that? I would divide by 3, because multiplication and division undo each other. So if I divide by 3, it's like it never happened. I multiplied by 3, I divided by 3, so I'm back to x where I started, and I've got the variable isolated. If I divide by 3 on this side, I must divide by 3 on this side to keep it equal. So 90 divided by 3 is 30. So I've got my solution, and the last thing you should do is check it by plugging it in, and sometimes, guys, you can do this mentally, so let's try it. Let's say x is 30. So this is 30 times 3, which we know is 90. 90 minus 4 is 86. And then I know I'm correct. Okay, so you will see something on the next video that require a 2-step where you have to do inverse operations a couple of times in order to isolate the variable. I want to show you one thing real quick that I forgot to show you earlier. I was going to on those 1-step equations. So last one here. If I have y divided by 5 equals 22. A lot of kids will make mistakes on this problem because they're not thinking about correctly. If you're using inverse operations, guys, this, remember, is y divided by 5. A fraction bar means divide. So if you divided by 5, how do I undo that to get y by itself? You actually multiply by 5. If I divide by 5, then multiply by 5, it's like it never happened. So y is by itself. Then I must multiply by 5 on this side as well to keep it equal. And that becomes 110. And guys, the most important way to do this, when you plug it back in, you got to do the work real quick to make sure it makes sense. But if you take 110 divided by 5, you will get 22, and it is correct. So sometimes people think times by 5, and they end up doing some things a little bit differently than they should there. But in this case, hopefully you see that and that doesn't confuse you, okay? So several examples there, guys, on your journal page. Practice using inverse operations. It looks easier when you watch it happen. If you do it, you're going to run into problems sometimes that don't make sense. So do some practice before you end up doing the exit slip. Make sure you watch both videos today, okay? And we'll talk to you guys later.